start. This is lesson 1-3 in advanced geometry. Today we're going to talk about array. So array is part of a line with one endpoint. Part of a line with one endpoint, that's array. And name an array is very tricky. It can only be named one certain way right here. Here's how it's typed out for you. Arrays are named by two letters only, right? The endpoint must come first and then any other point on that array. So I'm a highlighter guy. See this thing right here? Isn't that array? Doesn't that go on forever in one direction? It's part of a line with one endpoint. A lot of people always ask, why is that an endpoint? Why isn't it like called the start point? You know, because doesn't it like start there and then go on forever? It's called an endpoint because if you was to follow this pen to the right, how long would you go on? Forever and ever and ever. If you would follow it to the left, would it come to an end at M, right? That's why it's called an endpoint, because that line ends at point M. So let's name this array right here. Let's do that. In number 1, it says name the array at the right. You got to start with the endpoint. What's the endpoint of that array? So it's got to start with M. Then any other point on that array. You got choices. Name me a point. O is one of them, right? So what if I was to actually get my pen to work? Can we just call it that? That means what? The distance from M to O, right? What if I did this? What does that mean? Line MO, is that what we want? What if I had no arrows on it? What's that called? We want ray MO, which looks like that. Ray MO. There's another name for this besides ray MO. What else could we have called it? Not MP. Got to say it right. What do you want me to, what do you want? Ray MP. Does that sound okay? Those are the only two options. Let's talk about why some of these don't work. Why not ray OP to describe that red ray? Why not ray OP? O is not the endpoint, correct? So it can't do that. Why not? Come on. What is wrong with you? Why not ray MOP? Ray MOP. Why not? Why not that? Can only be two letters. Cool. How about this? What do you think about that? It doesn't work, right? Let's say your ray was this. Here's a picture. Isn't that a ray right there? And it's kind of going to the left, if you will. It doesn't matter which way this ray goes in your picture. What's the name of that ray? It must always be written like that. Endpoint first, other point second. This bar, this ray bar, always points to the right, regardless of how this picture goes. Cool? Let's draw ray QT with a straight edge. So let's draw ray QT. Yep, it's a good looking ray. It's a cutie. There's my ray. Only one arrow on it, right? One arrow. Which one's the endpoint of ray QT? Q, so that goes here. And T goes on that ray somewhere. There's ray QT right there. Good looking ray. It's a cutie. We feel comfortable with a ray. Next, an angle. Here's the definition of an angle. You've heard of them before, right? You've seen them before. But what is an angle officially? It is formed by two or more rays with a common endpoint. An angle is formed by two or more rays with a common endpoint. So you can pause the video and write that down. In my picture here, do you see I have a blue ray and I have a green ray? Awesome. Blue rays are nice, you know. My Blu-ray player. But this is a blue ray and this is a green ray, correct? Aren't those two different rays? Do they have the same endpoint? What is the endpoint of the blue ray? X. What is the blue point of the green ray? X. The combination of those forms an angle, right? An angle is formed by two or more rays with a common endpoint. What if I put a W right there? Now there's a bunch of angles in there, but don't they all have a common endpoint with them? Are we cool with that? The sides of an angle, let's just go back to a nice simple picture. The sides of this angle, real simple. The sides of those are the rays that make up the angle. 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 So here's what I had. I got to redraw it. But how many rays make up that angle? two. So if I asked you to name the sides, wouldn't one of them be ray XY and the other one be ray XZ? Doesn't that kind of make sense right there? Those are the two rays that make up that angle. Those are the sides of it. And then this is an important word, the vertex of an angle. The vertex is the common endpoint of the two rays. It's the common endpoint of the two rays. The common endpoint of the rays that form the angle. What is the common endpoint of the rays that form this picture? X. X is the vertex. It's just a point, right? X was the vertex of that angle. Okay? And now the next thing, whoa, my bad. The next thing that we got going on here, this drives me bananas because it is such an easy concept, but there are many students who have trouble with it. Let me tell you this. It's cool if you have trouble with it, but come get help immediately. Don't let this next concept of how to name an angle throw you off because it will mess you up for the rest of this school year. Let's fix it right away if you struggle with it. First, we've got single angles and we've got multiple angles. Can you kind of tell that in this picture, how many angles do you see? One. Down here, how many angles do you see? There's a lot more than three, my friends. There's a bunch of angles in that picture. I'll show you. Here's one, right? Here's one. Here's one. Here's another one. Here's another one. There's a bunch of angles in that picture. There's even more than that. But would you believe that there's more than one angle in that picture right there? So naming single angles versus naming multiple angles. Sound okay? So first, how do you name a single angle? There's three different ways to do it. First, we use the angle symbol. Do you see that? That is the less than symbol, my friends. Angle symbol, wah, swoop through it. The problem is the way the book types stuff out is they don't use that. They use this because there's a little bit of difference between the less than symbol and the angle symbol. I don't care how you read it on a typewriter. However it was typed out, it doesn't matter. How will you make an angle symbol? Like this. You'll make that with a swoop through it so it doesn't look like a less than symbol. Does that sound all right? So that's how we will always make angle symbols. So we can name an angle, if it's a single angle, by the angle symbol and the vertex. So let's do that over here. What is the vertex of this angle? Is it A, is it B, or is it C? What is the vertex of it? So we can call that angle A. We can't just call it capital A, because doesn't that just mean point A if it only had a capital letter there? So we could call that angle A. Sound all right? The other way to name any angle is the angle symbol followed by three letters, but the vertex must be in the middle, and the other two letters, one's got to come from one ray, the other's got to come from the other. So would you agree there's a green ray there, and there's a blue ray right there? Okay, let's name it angle. What's the vertex again? So that has to come in the middle of your three letters. We could call it angle BAC if we wanted to, because there's an A in the middle, and B's on the green ray, and C's on the blue ray. All right? What's the other way we can name this by three letters? Angle CAB is also a possibility. Is that okay? Cool. I want to show it to you in the picture now. This is where kids have a hard time finding angles. Is if I say find angle BAC, they have a hard time with that. Well, watch me highlight it. BAC, go from point B to point A to point C. You see how I just traveled from B to A to C, and that found the angle for me? There's angle BAC right there. Okay? Now, that's the second way. You can always do that. The third way is if they have a little number inside of there. Do you see that little number inside of that angle right down there by the vertex? Notice it does not have a degree symbol. It's not saying that that is a 1 degree angle. We could call that angle 1 if we wanted to. But the only time you can use a number to call an angle by a number is if that number is in the picture already. You can't put a number in a picture. Just like you can call a line by a lowercase cursive letter if it's there. But if it's not there, you got to call it the other way. So single angle. Are we cool with how to name those? Okay. Now we got a multiple angle. So let me make up a real life example. Multiple angles you cannot call by the vertex. Okay. You cannot call it by the vertex. Here's my real life example. Let's say I had two people in this room with the same first name. Right? There's not at this case. I don't believe so. But let's say I have Hannah Thomason in here, and I have Hannah Unrein in here, and I have Hannah Bonenstiel in here, and I've got Hannah after Hannah after Hannah after Hannah. Don't they all have the same first name? And if I just said this, Hannah, you've got a detention after school, that's not good enough because it's not very specific. Isn't there more than one Hannah in the room? I would have to say, Hannah Thomason, you've got a detention after school because I named that person by their full name, right? Very, very specific. So if you look in this picture right here, I want to highlight you many angles. See this blue angle right here? See this red angle right here? See this green angle right here? Could you tell me, blue angle, what's the vertex of the blue angle? R. Red angle, what's the vertex? R. Green angle, what's the vertex? It's like saying, oh, angle R. Well, which one of those is angle R? They're all angle R's. So you got to call it by its full name. You got to use 3 letters. That's like saying Hannah. Oh, wait a minute. There's 3 different Hannahs in the room, right? You got to use full name. If there is more than one angle in the picture, this is so difficult for so many students. If there's more than one angle in the picture, you must use 3 letters. Can we name this guy? If my pen would work, can we name this guy by 3 letters? What is the name of that angle by 3 letters? Angle SRP is what you said? Why did you put R in the middle? Why couldn't you? Because it's the vertex. What's another way to name that particular green angle besides SRP? Angle PRS would be fine. Isn't that the same thing, right? That's that guy's full name. So here it says you can use the angle symbol and the 3 letters. The other way is, could you call it angle 1? Is there a 1 inside of that angle on the interior? You can call that angle 1, right? How about this angle right here? That's an angle. What's the vertex? R. How would you call it by 3 letters? Angle SR, is that a Q? Is that a Q? Angle SRQ. Could you call it angle QRS? Yep. Now could you call it angle 1 plus 2? No. You see how it's got more than, it doesn't have a number in there, right? So got to call that one by 3 letters. Are we understanding the difference between a single angle, where that's the only angle in the picture, or a multiple angle, where there's many, 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 many angles in that picture? Sound okay? Awesome. Let's measure an angle. Grab your geometer and let's learn where the protractor is on that bad boy. So if you're watching the video, you need to come on in and I will show you how to use the protractor to do this part. Okay, so we'll skip to the next section. So to draw a nice straight ray, or draw that with your straight edge, then this is going to be the vertex of our angle right here. Cool, that point right there. So put the whole of your protractor right here and put the black arrow on top of the ray that you just drew. And now onto the back side, where things you definitely know already about right angles, acute angles, and obtuse angles. You have heard of those before, correct? So what's a right angle? Measures 90 degrees. You've seen the box before also. Like if you have a right angle in a picture, you should put that box. Right? If I draw this as perfect with a straight edge as possible, is that a right angle? Yes or no? Not at all, right? What makes it a right angle according to the picture? Box. Acute angle measures how much? Less than 90, but also more than how much? 0. So that's why that's what that says. That says the measure of angle B is greater than 0 degrees, but at the same time less than 90 degrees. And then an obtuse angle measures more than, but less than. So let's talk about some stuff in person. Classify each angle as right, acute, or obtuse, then use a protractor to measure the angle to the nearest degree. Angle MRP. Hardest part is finding angle MRP, if that's what it says. MPR. I knew I said it wrong. Angle MPR. My bad. Angle MPR. Want to make sure I'm right. If you can't find it, I highly suggest that you grab a highlighter. Up to you. That's not what I want. I want the thickness. It's up to you. MPR from M to P to R. Isn't that angle MPR right there? So what do you feel it is, first of all, just by looking at it? Right acute or acute? Okay, so let's measure it first just to make sure. So let's grab our protractor, and we put the whole of our geometer right here on the vertex. It would be the wisest idea to put the black arrow on top of this ray, ray PR, the one that's pointing to the right. And then here's the question. Does this little dude right here, does it reach your protractor numbers?
No.
So should you guess? No. Nope. Remove geometer. Take the straight edge and extend all of these out longer. Take your straight edge and extend all of those out longer. So we got them longer. Now let's measure that bad boy. Let's put the whole of our protractor on here, black arrow on there, and you tell me how much is that thing. 120 degrees. Sound good? Then we'll classify it right after that as what kind of angle. Cool. Next one, angle RPN. Well, let me find it for you also. RPN. Isn't that this angle right here from R to P to N? I don't need a protractor to measure that one. Why don't I need a protractor to measure that one? Box. How much does it measure? 90 degrees. What kind of angle is that? Right angle. And then finally, the angle they want us to measure last is angle NPS. NPS? Interesting, huh? Isn't that this blue angle right here from N to P to S? Y'all cool with how I'm finding these angles? I just kind of like tracing over them, NPS, right? How you measure it, where's the whole of your protractor got to go? On P. Then the black arrow's got to go on one of those rays, so you're going to have to like either turn your protractor or turn your paper a little bit. I would personally put the black arrow on top of this guy. All right, put it on top of that guy and see where that thing goes. If you need help doing that, let me know. I'll come around and help you line that up right. Just say it was 45 degrees. What kind of angle is that? Acute. It's very similar to this ray right here. That ray we drew earlier. This is a QT, and this is acute. It's an acute angle, and that's a QT ray. Next, congruent angles. We talked about congruent last time. What's congruent mean in our own words? Same size, same shape. So congruent angles are obviously angles that are the same size, same shape. So there you go. They're angles that have the same measure. All angles are angles. They're always the same shape. For them to be the same size, they must measure the same amount. Like a 45-degree angle would be congruent to any other 45-degree angle, right, if they have the same measure. Groovy, groovy, groovy. And I don't know if I have a box around it on yours, but you should put a box around it right here. Angles are congruent and measures are equal. Either highlight it or put a box around it, whatever you got. But that's a big thing also. We were kind of talking about that earlier. Angles are congruent, so you can see it says angle MPN is congruent to angle RPN. Notice the symbols. Did we use a little letter M in front of those? Nope, because angles are congruent. These are always talking about angles. These angles are the same size, same shape. But if I wrote this, what does the M mean again? The measures. What kind of symbol are you supposed to always use? Measures are equal. Angles are congruent. Measures are equal. The measure of these angles, if it was 45 degrees, would equal 45 degrees. The 45 equals the 45. But the two angles themselves, here's angle MPN, and here's angle RPN. Those are the same size, same shape. They're congruent to each other. Notice how they marked them in the picture. You see those cool little marks? We use tick marks to mark segments congruent. These are not tick marks. Do you see those marks in the picture, though? Those are called arc marks. Congruent angles get arc marks in them. Right? So now I can tell just by looking at it that those two measure the same amount. Sound cool? We all right? So an angle bisector. If I say bisector, what does that mean to you? Cut it. Bi means what? If you had a bicycle, what does that mean? Two wheels, right? So bisector means two equal sections, right? An angle bisector is a ray that divides an angle into two congruent angles. A ray that divides an angle into two congruent angles. Ray BA and ray BC are opposite rays. Opposite rays always form a line, okay? Isn't that ray BC right there, and here's ray BA right here? Aren't those opposite rays right there? It means it forms a line. Measures 180 degrees right there. Cool? So they tell you they're opposite rays. Then it says, so we've got opposite rays measuring 180 degrees. Then they say this. Ray BF does what? Bisects angle CBE. Well, first, let's find angle CBE. Find angle CBE, and maybe find it with your pencil highlight, or highlight it with a highlighter, whatever. It's a visual game here, man, this geometry. I hope that the highlighting is making things so much easier for you to see when I'm doing it. You should do the same thing. From C to B to E, right? Isn't that angle CBE right there? Cool? Now, what happened to it, though? Something happened. By ray BF. Didn't ray BF bisect it? Here's ray BF. I'll use a different color. Here's ray BF right here. This ray right here is like the knife that cut that green angle into two equal pieces. Cool? That red ray is like the knife that cut it. It bisected it. So we must mark that in the picture. Doesn't bisect mean it got cut into two congruent angles? Well, how in the world can I mark angles congruent in a picture? What are these things called? Not tick marks, arc marks. Boom. You got to do it. Now, do you see how I staggered those arc marks? Let me make them again for you while you're watching. I put one here, booyah, and one here, booyah. They're nice and staggered, as opposed to putting it like this. Boom, boom. Because it's hard to tell that there's two different markings there. That might look like one big arc mark right there. So stagger them a little bit. Is that cool with you? Awesome. They give me some information right here. What I'd like you to do, I'll do the first one for you. It says, read that to me. What's that say right there? M. It's not said out loud as M. Measure of angle EBF equals 6x plus 4. Right? Now, time out. Do you also see how the book doesn't put the little swoop through their angle symbol? Should you put the swoop through there? Yes. Okay? So measure of angle EBF equals 6x plus 4. Let's put that in the picture. That's the number one rule here in geometry. If you have information and you have a picture, you put the information into the picture. So measure of angle EBF, isn't that this guy right here? EBF, 6x plus 4. Awesome. Next bit of information. Measure of angle CBF. From C to B to F, right? It's 7x minus 2. So that goes in there. 7x minus 2. Is everyone okay with what I have done? It says for us to find the measure of angle EBF. Well, you can't just answer 6x plus 4. They have given us enough information to solve for x because of one magical word. What was really given to us in the instructions? If you was to pick out one word in here that was the most important word of all of that information, what was the most important word given to us? Boom. Bisects. Because what does it mean? That, okay, cuts it in half. So what do you know about those two? What do the arc marks mean? That these two measures are equal. Isn't this the measure of one angle, and this is the measure of the other one? And they're supposed to be equal. So how can I set up a cool equation to solve for x? 6x plus 4 equals 7x minus 2. Isn't that exactly what the arc marks mean? That this is equal to that. Their measures are equal. Solve for x. Pause the video, get that done. So now that we have found x, can we use that to help us find the measure of angle EBF? Can't we take 6 and, what's this called when you put it into place? Man, I could tell. It's called what? Substitution. There's no such thing called the plug-it-in property. It's called the substitution property. I know that poor math teachers have always said, plug it in, plug it in, plug it in. Well, we're going to learn that we justify everything we do with the property here. And it's called the substitution property. So can't we substitute 6 in for x? See if we can do it in our head. What's 6 times 6? Plus 4. So is this the answer to the question, 40 degrees? Nope. Is this the answer to the question, if I can put a B, angle EBF equals 40 degrees? What is the answer to the question? So I need a little m. Do it. There it is. Measure of angle EBF equals 40 degrees. Cool. We still had to use the arc marks because of the word bisects up there. Take this information, put it in the picture. Pause the video and get that done. Take this information, put it in the picture. Are we cool with that information being in the picture right there? So what do we do now? We want to solve for y somehow. How can we do it? Okay, so the easy way to say that is set these two equal to each other, right? Why? Why should we set those two equal to each other? Because that's what the arc marks mean. Because they got bisected, right? So let's do that. 6y plus 2 should equal 8y minus 14. And let's solve for y. Pause the video, get that done. Once you see you got the right y value of 8, answer the question. Don't we want to substitute 8 in for y right here? 6 times 8. 48 plus 2. 50 degrees. I'll just kind of put that there to help me, right? 50 degrees. Let's double check that, though. There's one way to tell if we did this right. Should the other one turn out to be 50 degrees also if they got bisected? So 8 times 8, right? 64. Take away 14. Did we do it right? Yes. Answer the question. What is the measure of angle CBE equal? I got to vote for 50 degrees, and I got to vote for 100 degrees. What do you feel is the right vote? 50 degrees or 100 degrees? It's 100 degrees. Where did the 100 come from? Because it's this blue angle is 50 degrees, and this green angle is 50 degrees, but I want the red angle, which is the blue one and the green one put together. Correct? 100 degrees. Does that kind of mess with anybody's brain a little bit? That's 100 degrees. That red angle is 100 degrees. Does that seem weird to anyone? The red one is 100 degrees. That's right. We did all the algebra right. 50 degrees plus 50 degrees is 100 degrees. What seems wrong about that, Bill? Looks like it's an acute angle, doesn't it? And here's the trick. It doesn't matter what the picture looks like. It matters what we did with our information. This is just a picture. And that's the number one weird thing in geometry is a picture is not necessarily drawn to scale every single time. Just because it doesn't look right. It's like, whoa, dude, I got 100 degrees and that's acute. You know, it's like that can't happen. Yes, it can if your algebra checks, right? Trust the algebra, not what the picture looked like. Sound all right? Let's move on. Boom. Take that information and put it in the picture. Pause the video, get that done. So, they gave me bisects in the instructions. Got to put the arc marks. They say the measure of angle PQT is 60. Oh man, PQT, isn't that whole green thing? How do you put that in the picture? You can't just put it right here because it's like, I want the whole green thing, so put it on the outside. Say like right here, this whole mamma jamma is 60 degrees. Okay? The whole thing out there is 60 degrees. Then they say measure of angle PQS from P to Q to S equals 4x plus 14. All right? Find the value of x. That's all I wanted you to do was put the info in the picture. We can solve this together. I need some ideas, though. How could I solve for x? Yes, ma'am. In there. So, since this angle got bisected and the whole thing is 60 degrees, we're going to say this is 30 and this is 30. I'm going to set 4x plus 14 equal to 30 because this guy got bisected. That's 60 degrees, so this is 30 and this is 30. So subtract over, and that gives me 26, right? 16, my bad, 16, and then x equals 4, correct? So now let's answer the question. What's the question? Find the value of x. Done. Let's set up the next one. All right, let's take that info, put it in the picture. Are the instructions the same? Yes, but the problem is different, correct? But the instructions are the same. Let's set it up. So again, the instructions were the same. So since that angle got bisected, I put my arc marks in there. They say this measure is 3x plus 13 This is 6x minus 2. And what do the arc marks mean, my friends? So let's set those equal to each other and solve for x. And then we'll answer the question. Find this, measure of angle PQT. So PQT is the whole Memma Gemma. Like I said, if you need a highlighter, use it. If you don't need a highlighter, don't use it. But 5 times 3 is 15, plus 13 more is how much? 15 plus 13 is 28. This one better turn out to be 28 also. So 6 times 5 is 30, take away 2 is 28, and then I'll let you answer the question. And get the measure of angle PQT equals 56 degrees.